Hello, my name is Herilalaina Rakotoarison, and I am pleased to present our paper on in-context Freeze-Thaw Bayesian optimization for hyperparameter optimization. Our study focuses on hyperparameter optimization. We know that manual tuning or grid search is very inefficient for this task because they are costly, time-consuming, and prone to error. So Bayesian optimization stands as a promising alternative to that by automating the search process. But still, traditional Bayesian optimization will not scale to expensive application. So that's where our work comes in. We focus on an extension of Bayesian optimization called Freeze-Thaw Bayesian optimization, and it aims to allocate resources incrementally to the most promising hyperparameter, which not only saves time and computational resources, but also ensure a better exploration of the hyperparameter space. So this Freeze-Thaw Bayesian optimization approach has two main components: a good surrogate model that allows to accurately predict performance, and an acquisition function that, based on this prediction, decide which run to continue or start. So some recent works, including DIPO and DPL, actually explored different choices of surrogate model and acquisition function. However, these two methods share the same limitations. So they both require an online training of the surrogate model, which not only increases the computational cost, but also adds additional hyperparameters. Regarding the acquisition function, these works considers a fixed designs of the extrapolation length, which might be suboptimal in some cases. So in our paper, we introduced IFPO, which stands for in-context Freeze-Thaw Bayesian optimization, which addresses all the limitations of the prior works. So we propose an in-context surrogate model, FTPFN, that does not need retraining or does not involve additional hyperparameters, making it faster and easier to use. We also introduce an adaptive acquisition function, MFPRandom, which we show empirically to be more robust than the existing acquisition function. Our surrogate model builds on the prior fit network paper by Müller et al. The main idea is to train a transformer on a dataset generated from a predefined prior. So in our case, we want a prior that captures the interaction between hyperparameter values and learning curve. And for that, we follow the same design as in LCNet proposed by Klein et al., and it consists of a combination of a Bayesian neural network and a set of parametric curves. So this gives us a complete pipeline that maps hyperparameters to its learning curves. So here are a few examples of curves dataset generated from this prior. And in our study, we trained a transformer on 2 million datasets using this prior. Here is a visual comparison of the prediction. And here you can see that our surrogate model FTPFN in the second column provides a better extrapolation of the curve and also a better uncertainty estimate compared to the two baselines. Importantly, the results hold for real learning curve from diverse models and tasks. Then we combine this surrogate model with an acquisition function that returns MFPRandom, and MFPRandom is actually based on probability of improvement with randomized extrapolation lengths. We also randomly scale the improvement threshold used to compute the PI. So this randomization makes the approach more robust compared to the fixed design choice in existing Freeze-Thaw algorithms. We now evaluate our overall approach IFPO, which combines the FTPFN and MFPRandom on several popular HPO benchmarks. So the results demonstrate that IFPO consistently outperforms state-of-the-art HPO algorithm on the considered benchmark, both in terms of rank and regret. So to summarize, in this paper, we introduced a new Freeze-Thaw Bayesian optimization algorithm called IFPO. It uses an in-context surrogate model that is not only more effective but also easier to use than the current models. And when combined with a simple acquisition function, our approach achieves strong HPO performance. If you'd like to learn more about IFPO, we'd be glad to discuss with you during the poster session. And in the meantime, feel free to check out our GitHub repository and optimize your pipeline with IFPO. Thank you very much.